So this is an XOR gate, and the idea of an XOR gate is that if one of the inputs is 1, then the output is 1, but if both the inputs are 1, then the output is 0, and if both the inputs are 0, then the output is also 0. And it's called exclusive OR because you want only one of the inputs to be 1. So it's pretty complicated, but I'll try explaining as simply as possible. So there are two places that connect to VCC. It's this resistor and this resistor. So this resistor feeds into this wire, and this wire goes into the source of this transistor as well as the positive side of this LED, right? And this transistor, the source of this transistor obviously connects to the gate, and this gate connects to a separate circuit, which I'll explain in a bit. So the idea is that this resistor goes to this wire, which goes to this LED, so and which goes to ground, right? But this LED is currently off, and that's because there's a current through this yellow wire over here from this resistor. So this resistor has a current in it, goes to this yellow wire, which feeds into the gate of this transistor, and that connects the drain and the source. And the drain of this wire is connected to ground through this orange wire. So the current is actually going through here along this gray wire, and it's going into the transistor, into the drain of the transistor, and out to ground. And now we come to the other resistor. So as I mentioned, the other resistor already connects to the yellow wire, which is why currently the transistor is off, which is why the LED is currently off, but it also connects to this orange wire and this gray wire. Now, if I click this button, it'll allow current flow through into this gate over here, into the gate of this transistor over here, which connects the orange wire to ground via this gray wire and the drain, right? So now if I click this button, the LED turns on, and that's because when I click the button, the current, instead of going through the yellow wire, it goes through the current. What the hell? It's because when I turn it on, when I turn this button on, the current will go from this resistor and then down the orange wire and down the gray wire into ground, instead of going into the yellow wire, which means that now when this button is pressed, it'll go through here, go through the gray wire, and now it'll go to the LED and into ground. And the exact same thing happens when I press this. It goes down, the current will go down from the second resistor into the long gray wire, into the short orange wire, into ground. So there's no current in the yellow wire, so the source and the drain aren't connected, so it'll go from the first resistor to short gray wire to LED to ground, and the LED turns on. But the important part is now that the inputs are also connected to these two transistors, right? So you'll notice that when I press this button, the current will go through here, and it'll also go through here. Similarly, when I press this button, the current will go into the gate of this transistor and the gate of this transistor. And what's so important is, if you notice that the output or the drain of this transistor is connected to the source of this transistor, and the drain of this transistor is connected to ground, and the source of this transistor is connected to the yellow wire to connect it to the red wire, and the red wire is connected to this resistor over here. So what's actually happening is, when I click either of these buttons, the current no longer goes to the transistor, so it'll go down the red wire, down the LED. And when it goes down the red wire, it'll arrive at this resistor, at this transistor, okay? And because this button is pressed, this source and this drain are connected, so it'll actually go from the source to the drain, down this brown wire as well, into this transistor, okay? And so what happens is, if both of them are pressed at the same time, you'll have two pathways for the electrical current. It can go, you'll have two pathways, so it can go from gray down the LED, or it can go gray down the red, down the yellow, down the brown, and to ground. Okay, and since this LED has a higher resistance than the second electrical pathway, it won't go through the LED at all. It'll go through only this. So it'll go down here, down the red, down the yellow, down the brown, down the second brown, and to ground. And that happens when both of them are pressed, which is why this is an exclusive OR gate, because when both of these buttons are pressed, no current goes through the LED, so it's off and the output is 0. So if I demonstrate, if I press one button, it turns on like it's meant to. If I press this, the other buttons turn on like it's meant to. And now, if I press both buttons at the same time, it turns off. You can see it turns off. And that's because current will go down when both of them are on, down there, down that electrical pathway, down out to ground, on the path of least resistance.